In the second example, oops, you cannot really see that. Okay, let's do this. In the second example, we are going to graph the curve of statical stability, for which we are given a table that gives a relationship between the heel and the writing lever GZ. The heel is to be plotted along the x-axis. That is what we do when we draw a curve of statical stability. Heel is along the x-axis and the writing moment GZ is along y-axis. Now it's a rectangular coordinate system or a Cartesian system, so x and y they intersect at a point 0, 0, and you can have a different reference here, but in this case we'll just pick 0, 0. And next thing we'll do is find the scale. So along the x-axis, that's pretty decent. We have 10, 20, 30, 40, 60, 80. So we can just label those divisions as 10, 20, 30, 40, 50, and 60. See, all those 50 is not in the table. The scale has to be consistent. We are still write 50 and we still write 70 and so on. So if you went from 40 to 60, that would be wrong. Now if you look at the y-axis, the values, they're pretty much every number is around 1. So say if I picked a scale of 1, 2, the graph will be just a small graph in this area, which is probably not going to give me enough information. So what I do, instead of picking 1, 2 as the scale, I pick a very small scale, let's say 0.2 for each major division. So 0.2, 0.4, 0.6, 0.8, 1.0, and 1.2. So now if you look at the scale along x-axis, each major division is 10 degrees, so each minor division will be 2 degrees, because there are 5 subdivisions. And along the the y-axis, every major division is 0.2 meters. So minor one will be 0.2 divided by 5, so 0.04 meters. Now we'll use all this information to plot the very first point. So our first point is 0.32. So from the x-axis 10 and from y-axis 0.32. Next point is 20, 0.71. So 20 from x and up, about in the middle of 0.6 and 0.8, so 0.71. And next is 30, 0.92, so x, and 9 again is in the middle of 0.8 and 10, sorry 1. Then we can find a point 0.92 over there. Next 40, 1.07, so 40 from x-axis, and 1.07. So we're just counting, so, right? 1.04, 1.08, so this is approximately 1.07. We don't have anything for 50. For 60, it's 0.97, so right about here. No point for 70, and for 80 it's 0.39, so just below 0.4. And the next thing is, of course, use your free hand to join all the points, so like connecting the dots, not straight lines, just a gentle curve. So this is how a curve of statical stability looks like. Now even if we join the point 0, 0 and the very first point, there is no writing moment when the angle of inclination is 0. So that's part A. In part B, you have to find the value of writing lever corresponding to an angle of inclination or heel angle of 35 degrees. So what you do is you find 35 degrees, which is right in the middle of 30 and 40, and you drop a line onto the curve, and where it crosses the curve, from that point you draw a straight line on the y-axis, and from there you can approximate the value of the writing lever. In this case it comes out to be 1. So at 35 degrees the writing lever will be 1 meter.